Ever wondered how a brilliant AI model, one that's been trained on tons of data, actually makes it from a developer's computer to that app on your phone? Well, today we're going to pull back the curtain on that crucial and often invisible journey.
And really, that's the whole point, isn't it? You could build the most amazing, future-predicting model in the world, but if it's just stuck on your machine where nobody can use it, it's basically just a very, very clever but totally useless file. It's an idea locked in a cage.
So, let's really dig into this problem first, the trapped AI model. We'll look at what keeps it locked up and prevents it from getting out into the real world, where it can actually do some good.
So you've probably seen a diagram like this before, right? It's the standard path. You get your data, you clean it up, you train a model, and then you check how well it works. But see that last step, deployment? That's the big one. That's where all the value gets unlocked. Without it, everything that came before is just a really cool science experiment. So what are the bars on this cage exactly? Well, there are 4 big ones. First up, accessibility. A bank teller or a doctor can't run a Python script, right? They need a simple, intuitive way to use the model. Then you've got configuration. The model needs to work perfectly on a Windows PC, a Mac, a phone, everywhere. Performance is also absolutely key. A movie recommendation that takes 5 minutes to show up? Useless. And finally, scalability. What happens when your app goes viral and 1 million people try to use your model at once? It has to handle that load without crashing.
All right, so how do we bust our model out of this digital prison? We need an escape plan. We've got to package it up and teach it how to talk to the rest of the world.
The very first step in this escape plan is something called serialization. The best way to think about it is like vacuum sealing a perfectly cooked meal. You're preserving the model and everything it learned into one neat little package. That way you can save it, send it anywhere, and then unpack it later, ready to go, without having to retrain it from scratch. And just like you've got different containers for different kinds of food, there are different serialization formats for models. Choosing the right one is super important. Pickle is great for simple stuff, but JobLib is way better for the huge data arrays you find in something like scikit-learn. What if you need your model to work on a web server and a smartphone? Then you're looking at something like Onyx for flexibility or TensorFlow Lite for mobile. Picking the wrong one can be a disaster. Your model could be slow, incompatible, or just too clunky to run.
Okay, our model is all packaged up. But now, how does it talk to anyone? That's where an API comes in. And the analogy here is perfect. Think of it like a restaurant menu. You don't need to go into the kitchen and tell the chef how to cook. You just look at the menu, the API, pick what you want, and the waiter brings it to you. Simple as that.
So picture this. Your app sends a request to a specific web address. The API, acting like that waiter, grabs the request and takes it to the model, which is the kitchen. The model whips up a prediction, hands it back to the API, and the API delivers it right back to your app. It's fast, clean, and super efficient. Okay, so our model is packaged and it can communicate. But where does it actually live? And how do we make sure only the right people get to talk to it? This is all about hosting and security.
Basically, you've got 2 main choices here. You could self-host it, maybe on a computer in your office, but if someone unplugs that machine, or if more than a handful of people try to use it at once, you're pretty much out of luck. That's why for any serious application, you go with cloud hosting. Platforms like AWS, Azure, or Google Cloud give your model a reliable, powerful home that can automatically scale up to handle millions of users if it needs to. But this leads to a super important, maybe even a little scary question. Once your model is online, it's out there for the whole world to see. So how do you put a front door on it and decide who gets a key? The answer? It's something called an API key. It's just a unique string of letters and numbers that works exactly like a digital key to your front door. You give one to every app or person you authorize, and they have to show that key every single time they ask for a prediction. No key, no entry. And trust me, these keys are absolutely critical. They stop random people from bombarding your server and crashing it. They protect your model's data and your users' data. They help you fend off security attacks. And they let you see exactly who is using your model and how much. It's your entire security and management system, all in one. Okay, theory is great, but let's see this stuff in action, right? In the wild. We're going to look at a case study of a bank that was trying to predict which customers were about to walk out the door. So, get this. There's this big European bank, and they are just hemorrhaging customers. They've got all this data, but they have no way of knowing who's about to leave. They need a way to get ahead of the problem. So what was their game plan? First, they built a really powerful model to predict customer churn.
Then, and this is the important part, they packaged the entire system. They built a simple little web app so any employee could use it, no coding required. And finally, they deployed the whole thing online so it was always available. Let's pop the hood and see what tools they actually used. For the model itself, they used heavy hitters known for accuracy. For serialization, Joblib was the perfect choice for packaging up all their data. For the user interface, they used Streamlit, which is fantastic for building data apps super quickly. And for hosting, they went with Hugging Face Spaces, a platform designed to make deploying models like this as easy as possible. See, every tool had a specific job to do.
And the result? This is the magic part. Instead of a complicated model trapped on some data scientist's laptop, the bank staff got a simple web page. They could type in a customer's info and instantly see if that person was a risk. It turned complex data into a real, actionable tool. That's the power of deployment. So, if we boil it all down, what are we really talking about? Deployment isn't just some final technical step. It's the bridge that connects your trained model to the real world. It's all about packaging it up and setting it up so that anyone or anything can ask it a question and get a prediction back. So let's just recap the big ideas one last time, okay? Deployment is what makes a model useful. Serialization is how you pack it for the journey. APIs are the universal language it uses to talk to everyone else. And hosting and security? That's what gives it a safe and powerful home on the internet.
So, I'll leave you with this. The next time you're using an app and it gives you that freakishly perfect recommendation, just take a second to think about the invisible journey it took. That little piece of intelligence was serialized, given an API, and hosted securely in the cloud, all to deliver that one tiny bit of magic right to your screen.